Today we're going to focus on AP problems. There is a PDF online, so print it out. I would try these beforehand and then go look and watch this video, or pause it right now and do this one. I know it is a little hard to read a little bit. It says a cubic polynomial function is defined by, so we have this cubic right here where a, b, and c are, or a, b, and k are constants. The function has a local minimum at x equals -1, and the graph has a point of inflection at x equals -2. So we want to find the value of a and b. Well, here we know that there's a minimum at x equals 1. Well, where do minimums come from? They come from derivatives. So what we're going to have to do in part A, we're going to have to find the derivative of this. Now, be careful. Okay, that's a 3 up there. So 3 times 4 is 12, and it's x squared. Plus, now that is a, so we're going to say 2ax plus b. All right, and then obviously k is a constant, and it goes to 0. Okay, so here we go. We know there's a inflection point at -1. I mean, not inflection. Okay, a local min at -1. So to find a, what we can do is we can plug in -1, or define a and b. We can plug in -1. And remember, since it's a minimum, it equals 0. So here, when I do -1 squared, I get 12. That's going to give me -2a, and then we're going to have plus b. Now, the inflection point, think about what inflection point. That's when the second derivative equals 0. So I've got to find the second derivative now. Well, let's think about this. That's going to be 24x plus, that's going to be 2a. All right, and we know here, when we plug in -2, it should equal 0. So when I plug in -2 here, that gives me -48 plus 2a. And I have something I can solve for a, and then I can plug it back in here to solve for b. Okay, so here I'm going to add the 48 over, equals 2a, and divide by 2. So a equals 24. Don't circle it, just leave it like that. A reader will find your answer. And make sure your work stays organized. Otherwise, if I'm grading anything, I need to be able to read it and find it, but also an AP reader as well. Okay, so here I know 0 equals 12 minus 2 times 24, because I'm going to plug it in there, is 48 plus b. So this is 0 equals -36 plus b, and so I get b equals 36. So I've answered part A. Always double check, make sure you answered it. Find the value of a and b. All right, we're good. Okay, now part B says, now this time I have an integral. And guys, any of these word problems, AP word problems, is going to have a mixture of derivatives and integrals. Okay, it says if from 0 to 1 of f(x) dx equals 32, what is the value of k? Well, we know what a and b are, so that I'm going to already plug that in. And I know from 0 to 1 of f of x, I'm going to go ahead and actually just put it 4x cubed plus, that's going to be 24x squared plus 36x plus k. And they say this equals 32. Well, let's think about what we did yesterday with integrals. Okay, so here, this would be 4x to the 4th over 4. Well, those cancel. Plus, all right, 24x to the 3rd over 3 plus 36x squared over 2 plus kx, and I'm doing it from 0 to 1. All right, and it's supposed to equal 32. So when I plug 1 in here, I get basically 1 to the 4th is 1. I'm going to do a little bit of this in my head, and I think you can too, being calculus students. Okay, now 24 divided by 3 is 8, and then when I do 1 cubed, so that's just going to be plus 8. All right, 36 divided by 2 is 18. Okay, so 18 and then 1 squared, that's just going to be plus 18. Okay, plus k. And now I would typically take all this and minus when I plug in 0, but think, all of these have x's. So that's just going to be 0. All right, so really I just need to set this equal to 32 and solve for k. Okay, so this is basically 9 plus, that's going to be 27 plus k equals 32. And subtract 27. All right, and let's see. That's 3, 2. Okay, so that's k equals 5. Not too bad, right? Okay, if you got that all by yourself, pat yourself on the back. All right, great work. Okay, let's go look at our next one. All right, our next one's this one. Again, go pause it and see if you can do it all on your own. Let f be the continuous function defined on the interval, closed interval, -4 to 3, and you see this goes from -4 to 3, whose graphs consist of 3 line segments in a semicircle centered at the origin, is given. And it says above, but this one's actually beside. Originally in the picture, it is above. Okay, so here we go. Find the values of g of -3, g prime of -3, and g double prime. Okay, let's think about this. G of x is basically the area under the curve. Okay, so g prime all right, g prime of x is actually just going to be f of x. And g double prime, and actually I'm getting ahead of myself. I meant to do a first. Let's go do a first. Okay, when I find g of 2, I'm just plugging in 2 in for that x right there. Well, all this is doing is finding the area from 0, or not 0, from 1 to 2. So from 1 to 2, what's the area of that triangle? All right. Well, think area of a triangle is 1/2, the base is 1, and the height, if this goes all the way down to -1, that's halfway, so that's just 1/2. So it's 1/4. Okay, and what did I forget? It's negative because it's below. So be careful about that. If it's below the x-axis, it's negative. And then g of -2. Now, we're going to use one of those properties that we learned yesterday. Okay, remember, a lot of times we like the greater one to be up at the top. So here, I'm going to change that to negative, and I'm going to change this, flip-flop these. All right, so here I'm going to have a negative on the outside, and I'm going from -2, which is right here, to 1. Well, notice I have this triangle right here, so it's the whole thing, so 1/2 times the base is 1, the height is 3, okay, plus you got to do this semicircle. However, this is below the line, so that's negative. All right, and it's pi, and notice the radius is 1, not 2, divided by 2. All right, so distribute the negative sign. So this is 3/2 plus pi over 2, or actually -3/2 plus pi over 2. All right. Now, part B. Part B is where we needed this stuff. So here I'm finding g prime and g double prime. Okay, g prime, think g is this, so the derivative of that is just going to be f of x. All right, and then the derivative of that is going to be f prime of x. Now remember, the graph is of f of x. So if I want to find g prime of -3, okay, think it's just the value of f of x at -3. So at -3, what is that value right there? It's 2. Okay? And then g double prime of negative 3, that means, think, the derivative means the slope of the line, the slope right here at negative 3. Well, let's think what it is. You rise 2, run 2, so it's positive 1. All right. Now, I'm going to flip over because I'm going to run out of room. Let's look at C, part C. Find the x-coordinate of each point at which the graph of G has a horizontal tangent line. For each of these points, determine whether G has a relative min, max, or neither. Okay, and justify your answers. Okay, let's look at it. G has a horizontal tangent. We'll think where G equals this right here. Okay, where does it have a horizontal tangent? Well, it's when G prime equals 0. Well, on the other side, we said G prime is just f of x. So it's basically where f of x equals 0. We'll look at our graph. Where does that f of x equal 0? At x equals negative 1 and at x equals 1. Now, are these max or are these mins? So here we go, and justifying your answers. So at x equals negative 1 is a, all right, let's look at this. Here this is positive and then negative. Okay, think positive is going this way, negative is going this way. So it goes up and then down. So it's a relative max because, now part of my work was this right here. So I can now just say f of x changes from positive to negative. And you can put the negative sign if you want. And then at x equals 1 is a, and think it's negative, oh, but negative. So that means it is nothing. It is neither a relative max or min because f of x does not change signs. All right, it has to change either from positive to negative or negative to positive for it to be a relative max or min. Okay, moving right along, D. For negative 4 to 3, find all values of x for which the graph has an inflection point. Explain your reasoning point. Okay, so inflection points, remember, is when g double prime of x equals 0, all right, as well as changes concavity. All right. So here, remember, this is the graph of G prime. All right. And on G prime, inflection points look like relative max or mins. All right. So where does it look like it has a relative max or min on our graph? Okay, well right here at x equals negative 2, okay, is an inflection point. Okay, and notice G prime, okay, of x, which is our f of x, okay, increases and then decreases. Okay, also at x equals, okay, where's the lowest point? Right here at x equals 0 is an inflection point because G prime of x, it decreases, then increases. And then also at x equals 1, it's an inflection point because G prime of x increases, then decreases. And you could have probably put -2 and 1 together if you wanted to in their justification, but make sure you explain your reasoning when it asks you to. All right, moving right along. Let's look at the third one. Okay, and these can take some time. All right, so here we go. A zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between, okay, that time and that time. The number of entries in the box, T hours after noon, is modeled by the differential equation E. Okay, so we see a table, values of E and hundreds of entries at various points are shown. Use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t equals 6. Show the computations that led to your answer. Now, if you notice, we don't have 6 here, and I want you to notice they're looking for a rate. Okay, rate is going to be basically the entries over the time. So if I want to approximate it at 6, find where 6 is in the middle. It's in the middle of 5 and 7. So we want to do E of 7 minus E of 5 over 7 minus 5. Okay, so this is going to be 21 minus 13 over 2. And I end up with 8 over 2, which is 4. Now, sometimes they tell us to make sure you put the units, and it doesn't show here. It does say show computation, so make sure you show your work. If I were to do units, it would be, notice I put the E of t over t. It's going to be entries over hours, entries per hour. All right, let's look at B. Use a trapezoidal sum with the 4 subintervals given by the table to approximate the value of. Okay, so we're doing this and we want to approximate this right here. Make sure you write this down. Now, I want you to notice that 1/8 is not part of the Riemann sum. The Riemann sum for trapezoids is just the integral part. So I will have to multiply it by 1/8 in the end. Okay, and I'm doing trapezoids. And I'm doing 4 subintervals. So here's going to be an interval, here's going to be an interval, here, and here. And I like to do that on my tables every time we do it. Okay, and it's a trapezoid. So the whole thing I'm going to have to multiply by 1/8. That's probably one thing people forget. Okay, remember area of a trapezoid is 1/2. The height of this trapezoid, the first one, is 2. And my 2 bases, remember I used both of those. 0 plus 4 is 4. Plus 1/2. Okay, the height of this one is 3. Okay, and my 2 bases, 4 plus 13 is 17. Plus 1/2. Okay, the height between these is 2. All right, and then I do 13 and 21, which makes 34. Plus 1/2. The height between 7 and 8 is 1. Okay, and then 21 and 23 make 44. For an AP, it's okay to leave it all like that. It has a final answer. However, we are going to find the final answer for this. All right, so take your calculator, go add all these together. You can do this by hand, but I'm just going to do this quickly. Don't forget the 1/8. You really get 85.5, and then you got to divide it by 8. So the final answer is 10.6875. Now let's think about this again. It says using correct units, so I do need to get the units. I took the integral of E of t. All right, and I'm finding. Basically, E of t is the number of entries. So if I integrate that, but then I divide by 8, I'm going back to the number of entries. The entries, so this is basically the average number of entries in the box between, and remember 0 was noon, between noon and 8 p.m. All right, so that's part B. Okay, be careful of the intervals if they put a constant out there and so forth. And be careful of your units. All right, moving right along. Okay, C. At 8 p.m., volunteers began to process the entries. They processed the entries at a rate modeled by the function, okay, P of T. Hundreds of entries per hour for 8 to 12, okay? According to the model, how many entries had not been processed by midnight? All right, so really what I'm doing, and they tell you that this is a rate. If I want to get the number of entries, I've got to integrate. Okay, so I want to integrate from 8 to 12 of P of T. And it's okay to write P of T if they already have it defined. Okay, so here, when I integrate that, let's say this is without a calculator, T to the 4th over 4 minus 30 T to the 3rd over 3 plus 298 T to the 2nd over 2 minus 976 T. All right, and I'm doing this from 8 to 12. All right, I believe this was on a calculator part, so really what you could do is this right here, and I'm going to use the calculator. We're integrating, so second alpha, and remember, scroll over, and we want to do number 4. We're doing it from 8 to 12. And then we plug in our function. Okay, our function is this right here. So x to the 3rd, all right, minus 30x squared plus 298x minus 967. If it is on the calculator, it will save yourself some time. And we ended up getting, and let's make sure I put everything in there correctly. All right, and I think I did. And I got 52. All right, my answer actually has 707. All right, I don't know where we're, oh, I know what it is, I think. All right, so we get 52 here when we're doing it from 8 to 12. And you know what? I see what I did wrong. All right, make sure you type this in right. I have my answer sitting with me, and that's how I know I did something right. It comes out to be 16. Sorry about that. I do make mistakes, and I'm not going to redo these videos. All right, so here we go. So we get 16. Double check everything you put into your calculator. Now, it says how many have not been yet processed by midnight. Okay, so this is the rate that they're processing. Now look, at 8 is when they stopped. How many were at 8? There were 23, and it's really 2,300. Okay, minus 16, and I get 7. And I've got to do this, and it doesn't say units, but if I'm doing units, what this means is 700 entries have yet to be processed. Okay, so 23 are the number of hundreds of entries that are there. This is the rate that they're being processed. So by 12 o'clock, this is how many they have not processed yet. Okay, and D, according to the model from part C, at what time were the entries being processed most quickly? So basically, think the greatest. Where is it the greatest? Okay, well that's at a max. Okay, that's where we can take P prime T. Okay, if I take the derivative of it, it's going to be 3t squared minus 60t plus 298. And I want to find the max of it. So where it equals 0. All right. Now, you also have to remember at these endpoints. When we did this, you have to say, okay, at 8 and 12 are my endpoints. And I've got to find the ones in the middle where it equals 0. So if I go to my calculator and I plug in 3x squared minus 60x plus 298, and I want to know where it equals 0. All right, I'm going to go ahead and change my window just because I know where it needs to be. I'm going to say 15. All right, and I've got 2 right here. And when I say second trace intersect, I got one of them to be, I'm going to go write it out, 9.1835, and the other one at 10.816997. All right, what you want to do is actually find the rate. Okay, so these are the t values. We want to plug it back into p of t. When I plug it into p of t, when I plug 8, I get 0. When I plug in this 9 point whatever, I get 5.088662. When I plug in this, and then when I plug in 12, I get 8. Which one's the greatest? It's right here. So the entries are being processed most quickly at t equals 12. Okay, so at 12 midnight. Okay, number 4. Now this one's a little longer than all the rest of them, so just hang in there. Okay, here we go. Use midpoint Riemann sum with subintervals of equal length. Okay, now since we're doing, it says 4, the midpoint, that means it has to be in the middle. 5's in the middle of 0 and 10. 15's in the middle of 10 and 20. Okay, 25's in the middle of these, and 35's in the middle of those. So when I do the midpoint, I'm wanting to use the middle value right here. All right, so to find 0 to 40 of v of t equals, or dt equals, all right, so we're going to do basically subtract 10 minus 0, which is 10, and then times it by 9.2 plus, all right, 10 times 7, okay, plus 25 times 2.4 plus, not 25, I'm sorry, from 20 to 30 is another length of 10, and then 10 times 4.3. All right. Once I plug all that in, I get 229. Now, using correct units, we have to explain. Okay, well, notice that we integrated velocity. So if we which is, I think it's miles per minute. Okay, if I integrate velocity, I get my position function. So, miles, all right, between 0 and 40 minutes. Okay, not only do they want the units, but they want to explain the meaning. Okay, so miles and all of that count. All right, part B. Based on the values in the table, what is the smallest number of instances at which the acceleration of the plane could equal 0 on the open interval? Okay, acceleration would be the second derivative, basically the derivative of this. And think, we want when the derivative equals 0. Okay, is where you're going to have, and that would be the acceleration. That's when you're going to have the acceleration equal to 0. So, if we think back to the mean value theorem, okay, is there anywhere where it's equal to one another? And if you notice, look at 0, t equals 0 and t equals 15. Do you see how they're the same? By MVT, if we did v of 15 minus v of 0 over 15 minus 0, we end up, because these are both 7, we end up with 0 over 15, which is 0. So therefore, and then the same thing here at 25 and 30, since these are the same as well, there's going to be 1 in between there. Okay, so at or on the interval from 0 to 15 and 25 to 30, A of t equals 0 for at least 2 values. Now, could it happen more in between there, and could it happen somewhere else in there? Yes, so that's why we say at least. All right, part C. And this one is another calculator one. Now, obviously, you can't do A without with a calculator. You actually have to show all your work for that Riemann sum. All right, the function f defined by is used to model the velocity. So we got to know this is the velocity of the plane in miles per minute. According to this model, what is the acceleration of the plane at t equals 23? Remember, acceleration is the derivative, okay? And I'm going to say the derivative of f of t. And we want it at 23, okay? Now, if this is a calculator active, please, please, please do not plug this into your calculator. We want to find f prime of 23. All right, so what I'm going to do is, remember how I showed you to find the derivative, okay? And I'm going to plug in the function. It's 6 plus the cosine of x divided by 10, close that parentheses. All right, plus 3 sine of, it's going to be 7x divided by 40. All right, and then, and actually I have an extra parentheses I need to delete. Okay, I'm doing this at 23. All right, so I get this to be negative 0.407. Remember, at least 3 decimal places. I'm just going to do it this way. Okay, and they want us to indicate units of measure. It doesn't say explain, so we just want to indicate units of measure, and that's going to give you a point right there. Now, I want you to notice we took the derivative of this. That's miles per minute. So this is going to be miles per minute squared, or you can say miles per minute per minute. All right, and then part D. According to the model F given in part C, what is the average velocity of the plane in miles per minute? Okay, so we're looking at average velocity. Basically, anytime you think average velocity is basically the integral over the time. So think integral over the time. So it's the integral from 0 to 40 of, let's see, of f of t, that's the function given in C, over 40 minus 0. Okay, if I were to do this in my calculator, okay, the integral, and I'm just going to give it to you. I think you can do that yourself. All right, and it's going to be in miles per minute. All right, and the last word problem that we've got. Okay, this was similar to one of those that we just did. Okay, we want to find the graph of the function. We want to find g of 0. Well, remember this. G of 0 is going to be, so it's basically the area underneath the curve from negative 3 to 0. So it's this trapezoid right here. So we're just going to say 1/2. The base is, or the height is 3, and the base goes up to 2 and 1, so for a total of 3. So this is 9/2. And then we say g prime of 0 Okay, g prime of 0 is basically, think f of 0. We want to know, and since this is a graph of f, what is that value? It's 1. Okay, moving on to B, find all the values of x in the open interval, -5 to 4, at which g attains a relative max, justifying your answer. Okay, remember, g has a relative max when g prime of x, or f of x, equals 0. Okay, well, where does f of x equal 0? Well, f of x equals 0 at x equals, let's see, that value is -4. And then this value is 1. And then the next value is at x equals 3. However, f of x needs to change from, let's see, think if it's a maximum, it's going to go up and then down. It needs to change from positive to negative. Well, think, that changes negative to positive at -4, so it's not that. Now at 1, it's positive and then positive, so it's not that. And then 3, it changes from positive to negative. All right, so therefore I have a relative max at x equals 3. All right, part C, I'm going to flip it to make sure I have plenty of room. Okay. Find the absolute min value of g on the closed interval. Okay, remember absolute, you have to try the endpoints. Okay, and we're trying to find the min from -5 to 4. Okay, well here, remember minimums occur when it equals, where this f of x equals 0. So at, say, -4, okay, and then we also, and if I go back, I don't want to try 1 because that's not a min or a max. I don't want to try 3 because I just realized that's a relative max. Okay, so I want to actually find values. Well, we know, let's see. So we've got to find what is g of -5. Well, remember, -3 to -5. Well, here, remember, we can flip if we want and put the greater number on top. But remember, we have to put a negative on the outside. Okay, so this is negative. Okay, and if I am doing it from -5 to -3, what occurs here? Well, they're the same, right? So that's just going to be 0. Okay, now we got to find g of -4. Okay, well that's from, think, -3 to -4 of f of t dt. I like to have the greatest number on top, so I need to put a negative out there. Okay, so here from -4 to -3 is this triangle right here. It's on top, so it's positive. However, I do have this negative, so it's negative. All right, it's 1/2. The base is 1, the height is 2, so this is -1. All right, and then we have to find g of 4. All right, g of 4, that's when we're running from -3 to 4 of f of t dt. I don't need to flip this one around. Okay, I know that this triangle right here, and I'm going all the way to 4. Okay, this triangle is negative, or actually, nope. That's 1 because it's on top. I can find the trapezoid, so it's 1/2. The height is 3, and we actually just did this. And the height, the two bases are 2 and 1, which make 3. Okay, I have this. Now be careful. This is like a rectangle minus a semicircle. So I've got to do the rectangle, which is 2 times 1, minus the semicircle. I'm going to erase this just because, which is pi 1 squared divided by 2. All right. And then I've got to do this triangle right here and this triangle right here, but what do you recognize? They're the same, so I don't even need to add those in there. Okay, so this is going to be 1 plus 9 over 2 plus 2 minus pi over 2. And you're honestly welcome to leave it like this. If you want to keep going with it, it's fine. And you know what? I added way too much in there. Did I even need to add this one? All right, no, I don't need to add that one. All right, because that was from -4 to -3. So please don't add that one in there. Sorry about that. And we could just honestly leave our answer like that if we want. All right, and then part D. Find the values of x in the open interval at which the graph has a point of inflection. Remember, it's where it looks like it has a relative max or min and changes concavity. Now, because this doesn't say why, we don't really have to explain, but it goes from increasing to decreasing, so therefore at x equals -3. Decreasing and then decreasing, so it's not there, but this is decreasing and increasing, so at x equals 1. This is increasing, decreasing, so at x equals 2. So this is where all the inflection points will be. AP problems, they give you about 15 minutes a piece on them on average, so make sure you can solve them. It is a lot of detail. If you can't answer one part, it's okay. We can answer another. You can try to answer all the rest of the parts. Okay, so just because you can't get one doesn't mean you can't get the next one. So just kind of keep trying. It is going to be a work in progress.